Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 14, 2025, about 6 days ago. The striking result is that narrow fine-tuning leaves clearly readable activation biases, and when those biases guide an interpretability agent, it identifies the broad fine-tuning objective more than twice as well, and nails specific details over 30 times better than simple prompting. The paper is titled, Narrow Fine-Tuning Leaves Clearly Readable Traces in Activation Differences, and the implications for model training are quite significant. In short, the authors introduce activation difference lens, show steering reproduces fine-tuning style, reveal causal overfitting signals, and find that mixing pre-training data reduces these traces with trade-offs. Alright, the previous segment laid out the core idea. Figure 1 presents 3 model organisms and shows that activation differences on unrelated web text expose the fine-tuning domain. The steering column shows neutral prompts turning into cat praise, risky investing pitches, and recipe-style prose, which signals strong format and content drift. The patch scope column lists high-scoring tokens like cat, stocks, and culinary that directly echo the domains. The agent hypothesis panels summarize these cues and assign grades, with 2 perfect scores and a lower score for the cake example. So, Figure 1 showed vivid examples of format and content drift under activation steering. Figure 2 now quantifies that pattern across model organisms. The left panel reports token relevance, where activation difference tokens score far higher than fine-tuned or base averages, which signals that early activations encode domain cues. The right panel shows cosine similarity, with steered outputs approaching fine-tuning self-similarity, while unsteered outputs align with normal chat, so steering reliably pulls generations toward the fine-tuning style. So Figure 2 showed broad signal strength in activation differences. Figure 3 reports how an interpretability agent performs with activation difference lens access, comparing against black box agents with larger interaction budgets. The activation difference lens agent, with 5 interactions, reaches grades of at least 2 for about 91% and hits 4 for roughly 30%, which signals reliable identification of fine-tuning objectives. Even with 0 interactions, the same agent scores well, while the strongest black box with 50 interactions manages only about 39% at grade 2 and roughly 1% at grade 4. Alright, the previous figure showed position-wise agent stability. Figure 7 reports causal effects across 3 models, comparing fine-tuning traces in blue against random directions in red. The left panel with LLaMA 3.21b shows a positive loss change on fine-tuning and a clearly negative change on pre-training, which signals overfitting. The middle panel with Qwen 3.1.7b shows the same pattern. The right panel with Gemma 3.1b shows positive effects on both datasets, suggesting those directions became integral to the fine-tuned computation. Alright, the previous figure showed clear causal effects. Figure 8 examines mitigation by mixing fine-tuning data with unrelated pre-training text. The lower panels show that even a small 1 to 0.1 mix sharply reduces steering similarity to the fine-tuning set and lowers token relevance, so the readable traces fade. Increasing the mix toward 1 to 2 brings both metrics near baseline. The top panels report false fact alignment, which often drops under mixing, indicating weaker false fact internalization and a trade-off between debiasing and task strength. While the previous figure highlighted the trade-off from data mixing, the table summarizes the interpretability agent protocol, defining layers and positions, setting separate budgets for model interactions and agent tokens, and listing tools like logit lens details, patch scope details, steering samples, ask model, and generate steered. The evidence section advises seeking stable cross-signal agreement and overlap across positions. The decision procedure outlines forming hypotheses, collecting evidence, re-evaluating, and then verifying by talking to both base and fine-tuned models, with a final structured output grammar. Alright, 2 takeaways stand out. Narrow fine-tuning leaves clear, early activation traces that simple diff tools and steering can read, and an activation difference lens-powered agent identifies the objective far better than black box prompting. The broader implication is caution for safety, privacy, and model organism realism, with data mixing helping but trading off task strength. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.